Absolute value equations, the basics. Absolute value is the distance from zero. This means the absolute value is never negative or non-negative. I know many of you have always heard that, hey, the absolute value is always positive. So here, the absolute value is always positive, but wait a minute, or zero. How far is 7 from 0? It's 7, right? The distance. How far is negative 5 from 0? It's 5. Well, how far is 0 from itself? It's 0. The absolute value can be 0 or positive. It is non-negative. So to say the absolute value is always positive, and I may even say it from time to time, and I'll catch myself and say the absolute value is always positive or 0. Right? You got to throw the or 0 on the end there, because if you just say it's always positive, that's actually incorrect. All right? So when the absolute value equals a positive value, so when you have an absolute value equals to a positive number, positive value, there are two equations which gives you two solutions. When the absolute value equals 0, so when it equals 0, then there's only one equation, okay? One equation, one answer, one solution. When the absolute value equals a negative value, guess what? There is no solution, because the absolute value cannot be negative. So there's no way for it to equal a negative number or negative value. All right? So that way, if you're given an absolute value equation and it's equal to a negative, you can just stop and say, hey, there's no answer. There's no need for me to work it. And that's what you need to do. You need to recognize that from the beginning. All right? So let's jump right in and work on these. Absolute value of x equals 9. So if we talk about just this x in here, what can that x be? Okay? What can that x be? Well, the absolute value equals 9. What can go here, right? Well, I can put a 9 there, right? I can put a 9 there. So that tells me that x can be 9. Or I told you if absolute value equals a positive number, that's positive. Okay, then you get two equations. Okay, you get two equations. So what is my other equation? X equals 9, right? We already put that in. We said, okay, if we put 9 here, absolute value of 9 is 9. What else can we put in right here that gives me 9? What about negative 9? How far is negative 9 from 0? It's 9. So that tells me, oh, wait a minute. Or x can be what? Negative 9. So x can be 9 or x can be negative 9. So the way this actually works, okay, if you look up the definition in a book or whatnot, most of them are going to tell you that, hey, the absolute value, if you have something inside the absolute value, you take that equal to 9, or you put the negative like it was inside there, you're taking it out, okay? So what's in the absolute value can be negative equals 9. And what happens, I can divide both sides by negative 1, and I get x equals negative 9. It's how that works out, okay? So we'll talk a little bit more about that later, but that's the book definition. That's what a lot of things are there. A lot of teachers go that route. I actually say, look, if I have absolute value, it equals plus or minus this number over here. So I got a 9, that's the plus, and I got a negative 9, that's the minus, okay? That's what I have there, so I'm going to take this off here, but that's what's going on there. Technically speaking, the x is 9 and then negative x is 9, because the x and the negative x can be inside the absolute value. The absolute value of x is plus or minus. Okay, absolute value of something is positive or negative of that equals the other number. All right, so I'm just going with the plus or minus on the side with the 9. All right, so here, absolute value of x equals 0. So if we talk about that, we can say, oh, well, x equals 0 or x equals negative. Wait a minute. Negative 0 and 0 are the same thing. So there's really no need, right? And we also said when the absolute value equals 0, we have one equation. One equation. Uh-oh, I just erased part of my equation. X equals 0. When it equals 0, there's just one equation there. There's nothing else to do. There's just one equation, and I should have boxed this other one here. All right, so for my students, I don't know, maybe in somebody else's class, I don't want you to do this. I always want you to box your answers. Here's a way you can write it. You can write it negative 9 first, or a more common way to see this is plus or minus 9. Plus or minus 9, all right? X equals plus or minus 9. So let's look at another one. Absolute value of x equals negative 11. So a lot of students will just go, oh, negative 11 or x equals 11. Wait a minute. No. Absolute value is always positive or 0 equals a negative. When does a positive number equal a negative? Never. When does 0 equal a negative? Never. This one, no solution. There's no solution there. It can never be negative. So the absolute value of something can never be negative. So it can't happen. No solution. So it doesn't have to be just the absolute value of x. It can be 2x plus 5 in the absolute value. Those are absolute value bars. These are absolute value bars around this. Okay. So the absolute value is on a side by itself. That's when you compare it to positive, negative, or 0 to see what you have. So absolute value equals a positive number. How many equations do I have? I have 2. 2x plus 5 equals what? 13. Or what? Or 2x. I stopped on purpose because many of you want to say minus 5, but you never change what's in the absolute value. That's how I do it. You never change that. It equals negative 13. So let me pause here. Those are my 2 equations. And look, when you have absolute value, I tell my students all the time, if you're in my class, this is what you need to know. If you're in somebody else's, you need to find out what you need to know with them. But this works all the time. All right. If you're in my class and I give you an absolute value equation like this one right here and you don't write 2 equations, I'm going to count the whole thing wrong. Because you're telling me I didn't even know what to do, how to start this that has 2 equations. That's the first thing you have to know. Solving each one of those 2 equations is really simple and really easy. These are 2 simple linear equations they're 2 steps each. That's not hard. The hard part is knowing you have 2 equations here. But let me go back to the rule. You know, over here we talked about, I wrote some stuff in this area right here, and we talked about x was 9 or negative x was 9, right? So let's talk about that rule over here. This is why I think a lot of students do 2x minus 5. I'm not sure. I'm not sitting in the classroom in high school when you're learning this with your teacher and all this other stuff. But my guess is your teacher's doing it right. Okay? Your teacher's doing it right. A lot of people want to give teachers a hard time and blah, 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 blah. And sometimes I even do that too because I am a teacher. And sometimes I see things and hear things from other teachers and I think, hey, we got to get this better. We got to do this better. Okay? But I feel like most, if not all, your teachers are doing this correct. You're just getting confused. All right? So here's what they're doing. They're following the book. This is probably what their book says in 9th grade in algebra, or 8th grade or 10th grade, whatever. Whenever you take this and you do these in school, okay, they're doing this. 2x plus 5 equals, and I'm writing this terrible, or negative 2x plus 5 equals 13. That's what the book says. Like if you look it up, the property in the book is going to say take what's in the absolute value equal 13 and then put the negative in front of what's in the absolute value equals 13. And then your teacher's doing this. They're distributing this negative and they're putting minus 2x minus 5. And that's why you think minus 5. That's why every one of you go, 2x minus 5 equals 13. No, that's not what you do. It's negative 2x minus 5. They're changing all the signs because they're using the exact property that's in the book they're teaching from. So what I'm choosing to do instead, what I'm choosing to do is not distribute this negative. I'm choosing to divide both sides by negative 1. So then 2x plus 5 equals negative 13. And this is this equation, and this one is this equation. That's what I'm doing. I'm taking a variation of that, all right? But then I'm able to say, take this and never change it. Put it here, and then put it here. Never change what's in the absolute value. And then equals the positive and the negative of the number. That's how I teach to do it, all right? So if your teacher wants you to show this step with the negative here and distribute, then you need to do that. But you need to understand where it's coming from and why you're doing it. Okay? So there it is. That's why I think you have that. And some of you had the teacher in college that did the same thing, and many of you have that. I may be on an island on my own doing it this way. I don't know. Right? My guess is there's several teachers that do it this way out there. All right? So let's take some of this away here. So 2x plus 5 is 13, or we never change what's in the absolute value. 2x plus 5 equals negative 13. And by the way, that whole never change what's in the absolute value thing, I'm going to expand that to less thans, greater thans, that kind of stuff as we get to inequalities as well. All right. So here, 2x plus 5 is 13. So I'm going to subtract 5 on both sides because that's how I solve equations. And 2x equals 8. And then I'm going to finish this equation. I'm not going to go to the other equation and try to mix it up. All right. So then divide by 2. X equals, and maybe I'm the only teacher that ever did that, but early in my career, I would do minus 5 over here, and I'd come over here and do minus 5. And then I'd come over here and divide by 2, and I'd come over here and divide by 2 on the right. So I would do all that stuff. And I had to confuse my students, bouncing back and forth. When we solve an equation, focus on this equation and solve it, okay? And probably I shouldn't have boxed that, so let me take that box away on x equals 4. Because I have another equation here to solve, right? Solve that over here. So here, solve it. We're going to subtract 5. Same step, but not the same result. 2x equals what? It's not 8, it's negative 18. Two negatives, you add them together and keep it negative. And then we're going to divide both sides by what? 2. So that divides out. X equals negative 18 divided by 2 is negative 9. So now x is 4 or x is what? So we can bring our or down if we want to. So then x equals 4 comma negative 9. And if your teacher wants you to put the smaller number first, negative 9 comma 4, that's fine. That's generally an accepted practice, but there is no order. The other thing I want to point out, books and teachers sometimes require this little squiggly. I call it a squiggly bracket. I don't know the real name for it. Okay, and that, if that's the real name, it just sounds funny. But squiggly bracket, 4 comma negative 9, and then another one to close. So that says x is the set. That little bracket, that funny looking bracket there that I'm calling squiggly bracket, that is set notation. And so when you have a set, this is called the roster method, where you're listing out each element. And the roster method doesn't matter the order. Not in math. Now, if your teacher wants it negative, the smaller number first, you do what your teacher wants because you're in their class. Okay? So, but in true math, it doesn't matter. Okay? I choose not to put the squiggly brackets, but I actually teach out of books and have taught out of books that do that for all the answers. So then if you're on the online platform for that book, then they require that. So some of my classes throughout the years, currently in the past, have required that on the online platform. So if you're in one of those classes, be sure you're checking for that. If you're like, I know I got the number right, Mr. Guess I don't know why it's not counting right. Because you didn't put the squiggly brackets maybe. Okay? So here, 3x minus 5 equals 2. So first of all, before I even start it, no equations, one equation or two equations? That's right, two equations, because absolute value equals a positive number. Okay? So that means two equations. What are my two equations? 3x minus 5 equals 2, or what? Or 3x minus 5 equals negative 2. Remember, we never change the 3x minus 5. Never change the 3x minus 5. And remember, where that comes from, I'm doing this. And then I'm taking the negative and dividing it onto this side, okay? So again, if your teacher wants you to distribute that and says that's the only way they'll take it, I may not understand that, but you go ahead and do what they want because you're in their class, okay? So for my students, I will never tell you have to work something a certain way unless I'm trying to make sure you know how to do a certain property, okay? Like if there's 4 ways to do something and I want you to know each one of those 4 ways, then I may say, hey, use this method. And then at that point, you've got to do it that way. All right. But in something like this, never would I make you do that. All right. If you wanted to distribute the negative or move, equal to negative 2 on the other side, that's fine. Because some of you had great teachers who explained it well and you understood it well, and that's how you do it. And if you do it the way they taught you and it's right, it's fine. Just fine. So this is just a different way to do it. All right. So I'm going to add 5 to both sides. 3x equals 7. Divide both sides by 3. X equals 7/3. And over here I'm going to add 5 to both sides. 3x equals 3. Divide both sides by 3, and x equals 1. So 7/3 and 1. So then x equals 7/3. Let me fix that 7. That's pretty bad 7. 7/3 and 1. Be sure you put a comma in between there. Don't put like 1 and 7/3, like a mixed number or something. That wouldn't even, you're mixing a number with an improper fraction. That's crazy. But anyway, put a comma, put the word or, something like that, okay? It's not and, it's or. It's one number or the other number. So it's 7/3 or 1. So let's look at another one. 4x plus 1 in absolute value plus 5 equals 3. Do I know if this has two equations, one equation, or no equations yet? And you're like, oh, it's got 2. It's equal to 3. Is the absolute value by itself? No. So when you have absolute value, okay, when you have absolute value, and this is similar to some other types of equations that you will see in math, whether it's absolute value or if it had a radical over it, right, like a square root or cube root, what you typically do, the standard operating procedure here is to get that thing by itself. So you're going to treat this like it was a variable y. So if you had y plus 5 equals 3, what would you do? You would subtract 5 from both sides and you would get y equals what? -2? That's what you would do. So we're going to do the same thing here, except we don't have y. We have the absolute value. We have all of this stuff instead of y. So what I want to do is I want to get this by itself. I got to take this 5 and move it over here. All right. So how do I do that? I subtract 5 from both sides. That cancels, and I get 4x plus 1, and it's still an absolute value. If you'll notice, when I write mine down, I exaggerate them and make them much larger because I don't write very neat, and I might think that's 14x plus 11 if I don't. So I would suggest when you write it down on your paper, okay, that you exaggerate your absolute value lines just a little bit, okay? I mean, they're a little, like if you look at this, they're just a little bit longer there. They're just a little bit taller there, all right? So, but I exaggerate mine to make sure I don't think it's, because some of my numbers look longer anyway or taller or whatever. So I don't want to think it's 14x plus 11. Absolute value of 4x plus 1 equals -2. Wait, absolute value equals what? A negative, right? So again, this side on the left is positive or 0, and that equals a negative on the right. So guess what? That is no solution. But I had to do some work first to figure that out. I had to subtract the 5 from both sides to know, hey, absolute value is equal to a negative. No answer here. No solution. Not going to happen. So let's see what we have next here. Absolute value of 5x plus 4 minus 6 equals 10. So again, we have something on the side with the absolute value. So we need to take and move this over. How do we move that over? We're going to add it to both sides. So 5x plus 4 in absolute value equals what? 16. Now absolute value equals a positive number, so I have what? Two equations. I'm done talking about that whole distributive negative thing. I'm just going to do what I do, all right? So I'm going to do what? I'm never changing this. Never changing that. I have 5x plus 4 equals or 5x plus 4 equals. That's what I have. Two equations. Start the same way all the way through the equals. One of them is equal to 16 and the other one's equal to what? -16. Those are my two equations every time. Every time, never changing that 5x plus 4, never changing what's in the absolute value, never, never, never. Okay? So then, how do we solve this? We subtract 4 from both sides, so 5x equals 12. We divide both sides by what? 5x equals 12 over 5, or 12/5. Oops, I don't need to box that, because why? I have another equation that I need to sit here and solve over here, right? So how do I do that? Well, I'm going to do the same steps. I'm going to subtract 4, and then that cancels out. 5x equals what? -16 minus 4 this time is -20, and then we divide both sides by what? 5, and so x equals what? -4, and I was about to box that one too. So now my answer is what? I have x equals 12/5, comma, -4. X equals 12/5, comma, -4. So those are my two solutions. And it could be -4, comma, 12/5. All right? But again, the first thing I had to do there was move the -6 from the left side to the right side. I need to get the absolute value by itself. Get the absolute value by itself. Solve for that like that was y or z or m or x, some variable by itself. So here we have 3 outside the absolute value. So 3 times something plus 6 equals 15. So I want to get the absolute value by itself. Now, it's not as important if you have a coefficient like 3 out there. You could leave that there. But again, rather than leaving it there, why don't we go ahead and say, okay, guess what? Let's get the absolute value by itself completely and then do my 2 equations, if there are 1 equation or no equations, okay? So here, I'm going to move this first, right? We undo addition and subtraction first. So there's no fractions here to change. So 3 absolute value, 2x minus 7 equals 9. 15 minus 6 is 9. Then I need to get rid of this 3 right here. How do I do that? Divide both sides by 3. So that divides out. 2x minus 7 is still in what? Absolute value. 9 over 3 is 3. Don't take the absolute value away. That's another thing that my students have done traditionally throughout the 3 decades that I've tutored and taught. Okay? I've taught for over 2, but I tutored for a decade before that. So 3 decades of tutoring and teaching algebra and math. All right? All levels of it. And here, one of the things that students do, they do all this work, because you've done some algebra already, moving the 6 over, dividing by 3, and they just forget the absolute values there. No, you haven't dealt with the absolute value yet. So you got to leave it there. It's one of the things that math helps you with, is paying attention to detail. What have I done so far? What do I still have to deal with? I dealt with the 6, I dealt with the 3, but I still have to deal with the absolute value. It's equal to a positive number, so guess what? I have 2 equations. What are they? 2, so I'm really coming over here, okay? 2x minus 7 equals 3, or what? 2x minus 7 equals -3. Those are my 2 equations. Never change the 2x minus 7. 3 and -3, okay? So now we're going to solve. We're going to add 7 to both sides. We're going to completely solve this one. 2x equals 10. Divide by 2. X equals what? 5. All right, don't box it. You're not done. You still got another half of your problem to do, or another solution to find. Again, add 7 to both sides, but my result is not going to be 10 this time. 2x equals what? -3 plus 7 is 4, and then divide both sides by 2, and x equals what? 2. So here, x equals 5, or that's a big comma. I want you to think it's 512. X is 5 comma 2, or 2 comma 5. Don't put 52 or 25 though. Don't put 52 or 25. Put 5 comma 2 or 2 comma 5. All right, so let's see what we have next. Here we have the absolute value of 6x plus 17 equals 0. Let me see what color I use. All right. So the absolute value of 6x plus 17 equals 0. So it's equal to 0. That means we have how many equations? 1, because if we put equals -0, 0 and -0 are the same thing. Right? This absolute value is actually never positive because it's equal to 0. So if you said it was always positive, that's wrong here. This is just 0. That's it. So then if I solve this, I'm going to subtract the 17 from both sides. I get 6x equals -17. Divide both sides by 6. And I get x equals -17 over 6, and that's it. I can box that one because there's not a second equation. All right, but that's the recognition piece. You have to look at this problem and diagnose the fact, hey, guess what? Boom. 1 solution, 1 equation. That's it. Don't write 2 down. Don't tell me it's no solution. It's 2. It's one solution. One solution. And that solution is -17.6 after I solve it. So here, 8x minus 1 and absolute value equals -2. The absolute value is by itself and it's equal to a negative. So again, and I like to write this down to remind myself, and that way your teacher may know, hey, what are you doing here? Equals a negative. Positive and 0 never equal a negative, so the answer here is no solution. And to me, this is the why. A lot of teachers will know, why did you write that? Did you just guess because you didn't know what to do and you put no solution and got lucky? So that way, I don't have any questions. If you're in my class, write this down. Hey, can't be. You can even say absolute. You can even write out the words if you want to. The absolute value can't equal a negative. That's why. That's the why. That's what I'm writing out there in shorthand here. This positive or 0 can never be negative. So here, this is another one like the one with a 3 in the front, except this time we have a negative 5 in the front. So let's take this and see. And just because there's a negative there doesn't mean it's not going to work. We have to work it out and see what's going to happen. So again, I want to get the absolute value by itself. I need to get rid of this and get rid of this. So we undo addition, subtraction first. So we're going to subtract 24 from both sides. That cancels because it goes to 0. Negative 5 absolute 3x plus 2 equals what? Negative 20. Don't get here and go, oh, it's negative 20, I'm done. Right, so I said something earlier where I said you may not have to do that. Well, here's a case where you really don't need to try to rewrite this thing without moving that negative 5, okay? If it's a positive coefficient, you can probably get away with it. But here, so rather than, I get away with it here and not here, just always move the coefficient. So we're going to move the coefficient. That's what I said then too, was always move it. So divide by negative 5. That divides out 3x plus 2. Have I dealt with the absolute value yet? No. So put it in absolute value equals negative divided by negative is positive. 20 over 5 is 4. And I'm about to box that, and I don't need to box that because I'm not done. Because what have I not dealt with? The absolute value. Do I keep going? Am I done with this one? Do I have more to do? What do you think? There's more to do, right? There's more to do. So what is my more to do? Well, I'm going to come over here where I have a little more space and start up here. 3x plus 2 equals 4. Or what? 3x plus 2 equals negative 4. Right? Never change the 3x plus 2. And then I'm going to subtract 2. 3x equals 2 divided by 3. X equals what? 2/3. And over here, minus 2 on both sides. So 3x equals negative 6. Divide both sides by 3. So x equals negative 2. So we have x equals 2/3 comma negative 2. 2/3 comma negative 2. So let's see what we have next here. This will be our final one. It's got a fraction in it. Yay, fractions, right? So I tell you, or have told you, if you watch my videos, been in my class, whatever, I tell you, hey, I want to get rid of the fractions first. Well, here, I'm not at that solving situation yet because I have to get the absolute value equal to something, and then I make my equations if they exist, 2 of them, 1 of them, or none of them. And at that point, when I start solving equations, I'm going to eliminate my fractions. That's what I'm going to do. Now, other people would do this one probably differently. But again, to me, solve it the same way every time. And then you, as a student, when you start to see patterns emerge and you go, you know what, I could have done this first and it still would have worked out, then you can start changing the order and the steps because you've seen it and you've recognized it. Otherwise, it's just confusing. I could work 10 different equations with fractions in them, do them 10 different ways, and blow your mind. Why would I do that as a teacher? I don't understand that. I'm going to work all 10 of them the same way every time and teach you the same way every time. That always works. And then when you begin to see, hey, the first one could be done this way, a little different, you can start doing that. It's okay because you've seen it. You've understand it now. Okay? You're getting better at it. You've practiced it. All right, so here, same way, absolute value equals a positive. So guess what? There are 2 equations here. So the first equation, 2x over 3 minus 1 equals 5, or 2x over 3 minus 1 equals negative 5. So the equation, the fractions here don't matter when you write the equations in the sense that I'm not dealing with them. I'm not having to get a common denominator or do anything like that. I'm just simply copying down what's in the absolute value equals 5 and copying down what's in the absolute value equals negative 5. And I have my or between it. That's a pretty ugly or, so let me fix it there. This says or, okay? That says or. So now when I come over here and I go to solve this one, because all I'm going to do is solve one at a time. I'm not going to bounce back and forth. Maybe I'm the only teacher that's ever done that, but when I first started teaching, I bounced back and I did one step on the left equation, then I jumped over and did the one step on the right equation. Came back and did one. That was crazy. I had to be confusing my students. That was crazy. I look back and go, man, what was I thinking? All right, so I'm going to solve this one completely. And the way I solve it, I say I got a fraction. What's my LCD? It's 3, so I'm going to multiply 3 times this minus 3 times 1 and equals 3 times 5. And again, I know another teacher, if you're real good at this, you look, why don't you move the negative 1 first? You can. But again, that's doing something different when I see equations. And there's so many students that I've run into in my 30-plus years tutoring or teaching that have trouble with this. A fraction pops up and they're like, oh my gosh, I hate fractions. I'm trying to give them one thing that they can grab a hold to and get good at and do it and succeed, because that's their goal. They're trying to pass a class, and fractions have given them fits for years. You see a fraction like this, find the LCD, which this is my only denominator, and multiply every term by it. And remember, I'm skipping the distribution. Really, you're doing this and distributing. I'm just showing each one here, okay? So I'm showing the distribution there. So then I'm going to come back here and say, okay, that's over 1. Those divide out. They don't cancel, divide out. 2x minus 3 equals what? 15. Then I'm going to add 3 to both sides. See, now it becomes 2x minus 3 is 15 is a super simple equation. That's why I multiply by the LCD. It makes it super simple, all right, compared to what we had. It still may be a tough equation. It's just a lot easier than it was. 2x equals 18, and then we divide both sides by 2, and we get x equals what? 9. So then x equals 9 for that one. But again, I didn't multiply by my LCD on both sides until I got to the point where I was actually solving the equation, not two equations from an inequality. That's the separating thing there. There's two different things going on. I mean, not an inequality from an absolute value. I said the wrong word. So here, what is my LCD on this one? It's also 3, right? So I'm going to say 3 times 2x over 3 minus 3 times 1 equals 3 times negative 5. All right. If it's, see how this is 2 terms right here? If it's 2 terms, I put the minus and then I put the 3 and then the 1. I mean, if you put, I could have put minus 1 times 3. It doesn't matter if you put the 3 on the left or the right. But I couldn't put, close my parentheses and put my 3 minus 1 like that, because then there's nothing here. So I had to put the minus sign first, okay? So that's what I'm doing there with that. And then on the other side, this is the only term, so that's why I put the 3 out front. But it would have been okay to do this. That's a little more confusing on that one, but you still could have done that. But it was one term, so. See what? Yeah, take those away. All right. So then 3 times everything. This 3 is over 1. Those divide out. 2x minus 3 equals negative 15. Same step, different result, because the negative 5 there, right? So then we're going to add 3. 2x equals negative 12. Divide both sides by 2. And what does x equal? Negative 6. So we get x equals 9 comma negative 6. 9 and negative 6. So there I wanted to put one of the fractions in here like that, but remember the fractions were inside the absolute value, so I dealt with the absolute value part first, where I put 2 equations, equal 5, equal negative 5. And then I went back, and when I solved each one individually, I found out, hey, what's the LCD? Let me multiply every term on both sides by it to eliminate fractions, and then it became something really simple to solve. Okay? So could I have solved this with less steps or easier in your mind or whatever? Probably. I could have. I'm an expert at this, okay? That's what I'm not an expert at a lot of things, but math's one of them, okay? So I could have, but again, it's because I've done so many of them that I know. When you're trying to learn, it gets confusing when you treat one fraction one way and another one another way, or equation with a fraction, I should say. So I'm always going to do this when I present to students. And then as students, they'll, if they raise their hand, Mr. Guest, can I do this? Yes, because you see that. That's fine. You can do that. All right? So I hope this helps out. Good luck as you work through absolute values.